Alright, today we're going to cover section 13.3 and we're going to learn how do you evaluate trig functions of any angle. Okay, so in your book, on the first part of this section on page 866, this is already written there, so it might be more clear there. But in general, I can find a coordinate anywhere and draw a circle through that coordinate and identify an angle theta and create a triangle inside of that circle. Okay, and I can label the r as the radius, and then the x and the y is the coordinate. Okay, so I'm over x and up y. Okay, so based on this triangle, using this angle, I can identify sine of theta as opposite over hypotenuse, y over r. Cosecant is the reciprocal of sine, so it's r over y. Cosine is adjacent over hypotenuse, x over r. Secant is the reciprocal of cosine. Tangent is opposite over adjacent, so y over x. Cotangent is the reciprocal. So that's just in general the general definition of a trig functions within a circle here. Okay, so let's do an example. Evaluate the 6 trig functions of theta if negative 4, 2 is a point on the terminal side of the angle. So let's just estimate where negative 4, 2 would be, somewhere like right there. So from there, I'm going to draw my circle, or my triangle, inside the circle. This is my actual angle theta. Okay, so this is actually negative 4, and this is 2 if I was to write that in there. Then I could find the length of that hypotenuse by using the Pythagorean theorem. So I'd have 4 squared, so it would be 16 plus 4. So it would be the square root of 20, which is equivalent to the square root of 4 times the square root of 5, so it would be 2 square root of 5. So that's what r is going to be, 2 square root of 5. Okay. So from there now I can just write out all the ratios. So the sine of theta is y over r, 2 over 2 square root of 5. So those are going to cancel. It's just 1 over the square root of 5, which I can rationalize and get the square root of 5 over 5. Okay. Cosine of theta is the x over the r, so it's negative 4 over 2 square root of 5, which is negative 2 over square root of 5, which I can rationalize and get negative 2 square root of 5 over 5. Okay, so that's that one. Tangent. Tangent is opposite over adjacent, so 2 over negative 4, which is negative 1 over 2. Okay. Cosecant. Cosecant is the reciprocal of sine. So sine was 2 over 2 square root of 5, so it's 2 square root of 5 over 2, which was just going to be the square root of 5 because those will cancel. Secant of theta is the reciprocal of cosine, 2 square root of 5 over negative 4, which is just the square root of 5 over negative 2. And cotangent of theta, reciprocal of tangent, so negative 2 over 1, or just negative 2. Okay, so all we have to do there is locate the coordinate, estimate where it is on that circle, draw your triangle, find your hypotenuse, and you can write out all your ratios. Okay. Now let's generalize it to a unit circle. A unit circle is a circle with a radius of 1. Okay, so if this radius is 1, and I looked at this little triangle here, like I did before, sine of theta would be opposite over hypotenuse, y over 1. Well, if the r is 1, then the sine of theta is just y. Same thing with cosine. Cosine is adjacent over hypotenuse, so x over r, which is x over 1. So the cosine, of theta equals x. So by definition, in a unit circle, a coordinate on the unit circle, the x-coordinate is the cosine and the y-coordinate is the sine. Okay. So in that case, let's look at what a quadrantal angle is. A quadrantal angle is an angle whose terminal side lies on an axis. Okay, so it would be these kind of angles: 0 degrees, 90 degrees, 270, 360. Those are all quadrantal angles. Okay, so if I was to evaluate the 6 trig functions for a quadrantal angle, like 270 degrees, I'd have to look at it a little more closely. So the sine of theta, remember sine is the y-coordinate over the radius, so it'd be -1. In this case the radius is 1, it's a unit circle, so it'd be -1 over 1, which is -1. The cosine of theta is the x-coordinate, 0 over 1, which is 0. Tangent of theta is the y over the x, so it would be -1 over 0, which is undefined. Can't divide by 0. So in this case, the tangent of 270 degrees is undefined. We'll see more reasons why in the future here. Cosecant is the reciprocal of sine, so 1 over -1, which is still -1. Secant is the reciprocal of cosine, 1 over 0, so that also is undefined. And cotangent is the reciprocal of tangent, 0 over -1. That's 0. Okay, we can't divide by 0. So in quadrantal angles, we have to consider these definitions and decide whether they are. The answers here are either positive or -1, 0 or undefined every time. Okay. Next part here, let's talk about reference angles. A reference angle is an angle formed by the terminal side of the angle and the x-axis. Okay, so for example, if I drew this angle here of theta, the reference angle is the angle it makes with the x-axis. So in this case, it'd be this angle here. Okay, so let's find the reference angle for -120 degrees. So if I draw -120 degrees, I'm going backwards 120 degrees. Be right here somewhere. The reference angle then is the angle it makes with the x-axis right here, the acute angle. So how many degrees is that? It'd be 60. So 60 degrees is the reference angle. Okay, if I'm in radians, I gotta think about where I am in radians. 5 pi over 3, if you think of pi over 3 as 180 divided by 3 is 60 degrees, where am I going to be around this unit, around this circle here? 3 pi over 3 is 180, so then I got to go another 2/3 of the way around, so it's going to be 5 60-degree angles. So it'd be somewhere like right here. That's 5 pi over 3. So then, what do I have left for a reference angle? Okay. Now think of it, 2 pi is the distance around the whole circle, which would be 6 over 3. So I'm 1 pi over 3 short of getting all the way around that circle. So pi over 3 is my reference angle, which is equivalent to 60 degrees. Okay. It's always the angle it makes, the acute angle with the x-axis. 8 pi over 9. Now we know 9 pi over 9 is pi, so that's 180 degrees. So we're not quite at 180 degrees. We're 8/9 of the way there. So my reference angle is this little angle here, which is pi over 9. 20 degrees, 180 divided by 9. Okay, so that's how we find the reference angle, and we're going to see in a minute why it's important. So reference angles allow us to evaluate trig functions for any angle. Okay, so this is very important. Here are the steps. We find the reference angle, we evaluate the reference angle, and we can evaluate reference angles without using a calculator if they're angles that are multiples of the special triangle angles, 30 degrees, 60 degrees, or 45 degrees. And then we determine the sign, whether the result is positive or negative. Okay, so if I think of a unit circle here, and I said before that sine is the y-coordinate of any point on a unit circle. So if that's my xy, sine is the y-coordinate. That means that where is y positive? It's in this quadrant and this quadrant. It's positive. Okay, so what I'm going to do is I'm going to write down where sine is positive. Okay, sine is negative down here because any y coordinate